In this video, we are going to look into measurement of serum bilirubin levels with the help of method called as Vandenberg reaction. Vandenberg reaction, you should remember that it measures either direct bilirubin or total bilirubin. Suppose this is your serum and the components of bilirubin in your serum, you are well aware now that the major component is unconjugated bilirubin, which forms major fraction, followed by a very small fraction of conjugated bilirubin, that is bilirubin monoglucuronide and bilirubin diglucuronide. There is a third component which is diazopositive compounds, and these diazopositive compounds are not bilirubin, but they are significant when we study Vandenberg reaction. Now what happens? We add a chemical called as diazotized sulfonilic acid. When we add this chemical to serum, the direct fraction or direct bilirubin, that is bilirubin mono and diglucuronide, gets converted into what is called as azopigments. These are azopigments, which is dipyryl methane, and they absorb light at the wavelength of 540 nanometers. And with a photometric technique, we can actually measure the amount of direct fraction of bilirubin. There is a fallacy when we measure direct fraction. The fallacy is that it overestimates the direct bilirubin fraction in the serum. Why it overestimates? Because as we know, there are certain diazopositive compounds, and these diazopositive compounds also react with diazotized sulfonilic acid, and when it measures both of these fractions. So it overestimates direct bilirubin. Newer methodologies have taught us that in the serum of normal human beings, usually conjugated bilirubin should be absent, and if it is present, it is usually bilirubin monoglucuronide, and that to be less than 3%. And in cases of hepatocellular jaundice, when there is a hepatic damage, amount of diazopositive compounds go up in the serum. So overestimation of direct bilirubin is much more in hepatocellular jaundice as compared to a normal human being. Now, how do we measure total bilirubin levels? The second part of reaction is same. In the first part of reaction, we add alcohol, which acts as an accelerator, which releases albumin from the unconjugated bilirubin, and now unconjugated, conjugated and diazopositive fractions are available for reaction with diazotized sulfonilic acid. So it measures total bilirubin. The fallacy of this method is that it underestimates unconjugated bilirubin. Why it underestimates? Because it is unconjugated bilirubin is slow to react with diazotized sulfonilic acid. That's why it underestimates unconjugated bilirubin. So when we have direct bilirubin, when we have total bilirubin, we can actually calculate unconjugated or indirect bilirubin.